Howdy, folks. My name is Gary Edgar. I am a technical support engineer at Commodore. At Commodore, we're developing a Kubernetes management system. It's a single pane of glass for easily managing your Kubernetes clusters, giving you a good view. It's cloud agnostic, so whether you're in GKE, AKS, regardless, we give you a nice overview. And we've been working on a pretty cool tool called Cloudia for automated root cause analysis. We'll be getting into that a little bit later. This originally, full disclosure, was not my talk, not my deck. Most of us were recently at KubeCon, so I am filling in for someone. Andre, actually, let me move over to our next slide here. If you want to see the original talk, Andre gave a pretty interesting workshop on this 8 months ago or so, so it's a little dated. After this, I want to sync up with our CTO, ETL Schwartz, and see if we can come up with some better material around this, because I just threw this together in the last couple of days/hours. So apologies, it's not very polished, but I'm hoping I can provide at least some interesting insights around your app and maybe your environment at home. A little bit about me. So, data-obsessed technologist, a home labber and tinkerer, and I love hiking with my dog. I've got a soft spot for Prometheus, Python, Grafana, and I've worked with MySQL databases my whole career, so might be able to provide some insights at the storage layer, thanks to that experience. But I'm just a big fan of turning data into insights and actions. Prime example, at home, I recently started dabbling with Raspberry Pis for DNS using Pi-hole, and that provided some interesting insight into just hidden signals in my own network at home. I know a lot of you are probably already monitoring your metrics around core DNS, but an interesting example at home, discovered you can see your data being sold in real time, like Roku or Plex constantly phoning home, sharing your data. So that was pretty insightful. Outside of that, I had another interesting little anecdote, also a public service announcement in case you have any relatives who happen to have a super box or one of those Android boxes that has 1,000 free channels or whatever. No, those are not free. You are the product. I used one of those more so as an exercise of hardening my own network, but was interesting just seeing all of the different shady things that were happening under the hood that your parents or someone less technically inclined might be unaware of. So it was actively selling. So I spun this up in an isolated little lab, but was able to see it's actively selling internet of yours through, there's a website that's getgreen.com or getgrass, I forget. It's not marijuana related, I promise. It's all about selling internet legally to institutions. So these Android boxes, a lot of them actually have that baked into the operating system. I just thought that was random, cool, but they're also using your IP address for spinning up new accounts and abusing referral fraud and click fraud, that kind of random stuff. Let's see. So this was a slide from the original deck that I thought was interesting. Kubernetes is both a blessing and a curse. It handles a lot of abstraction for you, but it's tricky to manage at scale, especially when you have many different environments, many different clouds, many different apps. Everyone can see the standard signals, but the important thing is turning those metrics from noise more to signals. The interpretation's the hard part. It's not just enough to collect metrics, traces, and logs. Context is essential. Without, say, baselines or thresholds, a metric is just a number. But when you start to understand what's normal, context then translates that into a signal. So here's a quick thought experiment. What are some hidden environmental factors, either in your home, office, or your workspace, or this meeting room, that could negatively impact your health or cognitive function? Here's one example, radon, but if anyone has any examples, I wouldn't call it swag, but I have some particulate matter sensors, if anyone has a Raspberry Pi or Arduino. Go ahead. A cat, pollen, dogs. This is another area I've really been nerding out at home. So this radon graph here, this is from my own home lab. It leads me into a little bit of an embarrassing story. I was living in Portland in a finished basement, and we had no air conditioning. I had a fan down there that was exhausting air out my window. And little did I know, I was actively poisoning myself by inadvertently sucking additional radon up through the ground. So if you didn't know, this whole region's kind of a radon hotbed, thanks to Missoula floods bringing a lot of granite down here. But radon, it's a silent killer. You can't smell it, you can't taste it. It's a pretty good metaphor for a hidden signal that's easy to monitor, but if you don't know to look for it, you're out of luck. Some other kind of hidden things at home that I've really gotten into that has led to actionable stuff where you can just take metrics but turn them into legitimate automation. Temperature, humidity, circling back to the particulate sensors I have, those are, sorry, this is a bit of a tangent here, but it's fun for me because I can graph Prometheus metrics, I can do alerting via PromQL, and automatically kick on air purifiers. It started with, we won't go into that, sorry. Fire season's never fun. Yeah, I moved here in 2017, and that was my first exposure, was actually Canadian wildfires polluting the air. This was a slide from the original deck. I'm gonna touch on it briefly because metrics, traces, profiling, they're not just enough. You need to look at this data with additional lenses. Timeline analysis is a big one. Is this normal right now? You need to compare your metrics against baselines or historical windows. Clustering analysis, who else is acting like this? So looking for groups of nodes, pods, and workloads behaving similarly. That's useful for spotting noisy neighbors, identifying systemic issues like maybe a kernel bug across a node pool. I'm not going to touch on this. That's not an area of expertise, but using dbScan, Andre talks about that in his talk, if you're more interested in that. Correlation analysis, what's moving together, so can help identify cause and effect. For example, are spikes in latency always followed by memory pressure on this sidecar pod? Useful for root cause analysis as well as service dependency mapping. And then misconfigurations and static analysis. That reminds me, I forgot to, circling back to this page, need to shout out Hen and Ilan, who have an upcoming talk around drift happens. So that's one powerful feature our product has, which is very good for detecting drift across clusters, across various clouds. So just had to do a quick little shout out of their upcoming talk. But a little bit background, why am I here? That's a really good question. So I've spent a lot of time in the storage and monitoring areas. So I started my career off at a company called Sev1. They do network and application performance management at scale. Think like very large CSPs, MSPs. And that really highlighted to me, this was my first company I joined, and just the power of baselines was immense and pretty eye-opening. So if you're not actively baselining your data, you're definitely missing out. A good real-world analogy is imagine trying to predict a storm without knowing what a clear day looks like. It could be 90 degrees in Texas, which might be normal there, but that could be a crisis in Norway. So without baselines, you really need context to understand when something's truly wrong. And that was one of my biggest takeaways from Sev1. They definitely do baselines the right way. If you've never worked with baselines, I think a pretty good default method for doing that is, say, aggregating like 15 minutes of data into a bucket and turning that into one data point, and then using, I don't know, think 900 seconds is a pretty good granularity for default baselines. Outside of that, sloped alerting, I think that wasn't something I immediately started working with, but thresholds are great, but they can easily miss things. Prime example is a velocity aware alert around, let's say, disk usage. So I've worked in storage basically my whole life. Let's say you have a disk that's 40% full. That might seem like, hey, that's no big deal. If that disk is filling up at 10% every hour, you only have 6 hours until that disk is totally full. So that's where utilizing slope-based alerting can be really powerful and give you just much better visibility into issues before they arise. Proactive disk management, listen to your disks. This is, well, literally and physically, figuratively. I can hear the disks in my server room spinning, but you really need to pay attention to the underlying metrics that they're emitting and replace them before things go haywire. And then finally, I think time over time analysis is pretty useful. So I've worked a lot with Prometheus and using a handful of other features like the offset function is pretty useful when you want to compare current values to historical trends, even when maybe an exact threshold might not have been crossed. Also, the random glider gun picture, that's just a shout out to my former platform team there. That was the name of our sprint team. But outside of that, importance of third-party data. So I originally started working within quality assurance at SevOne. Ultimately, I transitioned to professional services and worked in resident engineering. I actually worked not far from here for a while. I was on site at the Millennium campus for over a year, and we did a lot of custom ingesters around basically any and all data you can imagine, and just being able to incorporate third-party data into, regardless of whatever tool you're using, being able to normalize stuff and get it all under the same single pane of glass is super important. It just cuts down on time to resolve things. You don't have to bounce between different applications. And that's a continuing theme. And all right, apologies for the crappy slides. I know, I just added them not too long ago. But after SevOne, I worked at a company called PlanetScale. And I was actually pretty disappointed that one gentleman who was going to speak prior to me originally was all about how databases in the cloud are difficult. And I can assure you that is very much the case. So a little bit of history about PlanetScale. So PlanetScale was developed by a couple of YouTube engineers in the late 2000s when YouTube cat videos were taking over the internet. So they had a single MySQL instance that could not keep up with their massive scale. So a couple of their engineers stepped away, listed out all their different problems, and then they developed Vitess. Vitess is open source. They developed it at YouTube, but then ultimately donated that to the CNCF. So that's a fully graduated project. It's basically allows you to easily scale MySQL. So it looks like a single monolith, even though it could be many different shards under the hood. Why is this relevant? I did a lot of work around benchmarking, and it really highlighted a handful of needs. So instrumentation in general is one of the most important things, whether that's my crappy little Python app, which is scraping radon metrics and hosting those for me, or the performance of your disk or your Golang application. So Vitess is heavily written in Go, and it can be pretty CPU greedy. So I'm not sure how many Golang developers there are out here. I am certainly not one myself. However, pprof is super powerful and easy enough to add to your application. It's only a few lines of code, but it can give you all sorts of useful debugging information around Go routines, profiling, things of that nature. And that's super useful for debugging. Additionally, circling back to PromQL, tail latency is super important when it comes to extremely sensitive applications. One thing, PlanetScale actually, I think they're now exposing Prometheus metrics to end customers, which is great. But if you're not instrumenting your code into buckets around timing, you're definitely missing out, because PromQL, for example, has the histogram quantile function, which is super powerful for seeing things like P999. And that gives you a much better picture when you can actually see requests broken up into those specific buckets. Let's see here. A lot of my career is centered around storage, so that's where a lot of the hidden signals I've learned about exist. Specifically EBS volumes. I know CloudWatch has some pretty good metrics around that, but that's expensive, and there's a chance, let's say you have a load that is microbursting, you might not be able to see that within your CloudWatch metrics. If you're going past your IOPS limit, that might not get caught, so you might need to drill down into the actual disk. So that's where drilling into IOStat and disk metrics can be pretty helpful. Long story short, what I'm getting at is, even though I love network-attached storage, noisy neighbors are inevitable, and you're ultimately at the mercy of the cloud's infrastructure. And you can benchmark all you want, but there's a chance that you might just hit unintended latency just because someone's spinning up a new workload, and there's really nothing you can do about that outside of local storage reigning supreme. I know PlanetScale just released Metal, which is local NVMEs, which obliterates those extra hops. This is a story that's as old as time. I know when we were at Sev1, we did a similar experiment with Fusion IO drives hooked up over PCI Express that were comparable to RAM. So seems like same story, different decade, but we don't need to dive into all of this specifically. These are common Kubernetes metrics that, if you're not taking a look at, they can be very useful for predicting issues, but these are just good things to keep an eye on. These were slides from the original deck. I think we're going to skip these because we're running pretty low on time, and I am going to switch over to a quick demo of Commodore. While we still have a few minutes here. All right, so this is the Commodore UI. Oh, this is customer account. Let's not do that. Bear with me here. Gives you a nice overview, so you can see these are different Kubernetes clusters spread across various clouds. This is nice for developers and folks who don't have a ton of experience managing Kubernetes clusters. Makes it super easy to navigate through the resources. You don't need to be a kubectl expert. One of the most powerful things I think about Commodore is just its change tracking in general. You can get all sorts of information about your pods, your nodes, but that historical context is often lost because nodes and pods and everything, these are all ephemeral, whereas Commodore does a pretty good job of tracking all those changes and giving you visibility into that. Additionally, we have an events timeline, which is a pretty good overview. And circling back to the importance of third-party data, one cool thing you can do with Commodore is you can add in events from other systems, or if you have an alert set firing, you could automatically add that into Commodore. Arguably, the most powerful feature within Commodore is definitely our new feature around root cause analysis. So we have an AI agent called Claudia, which does automated root cause analysis. It's basically, our company was founded by SRE experts, and they've been able to translate that into this awesome tool. But sorry, struggling to read here. Let's go over to services. If I want to take a look at a random availability issue here, we dive into this. We can investigate it, and Claudia will do a automated kind of step-by-step analysis, basically mimicking what an SRE does. And additionally, we have correlated insights. So that's a lot of that under the hood scan sort of stuff. Sorry, The vision's not great here. And then, as I mentioned, we have a cool new drift analysis feature. So that talk is on the 22nd. If anyone's interested in learning more about that. Outside of that, where's our timer? Not sure where the timer is, but yeah, cool. Anyone have any questions? I do have a handful of those particulate matter sensors to hand out if anyone's interested. Any questions?
How long are the logs kept in Commodore? As far as user settable or whatnot?
I'm sorry?
How long are the logs kept as far as they're all ephemeral or whatnot? I was just curious.
Yeah, I want to say 30 days, Zach. Yeah, I think 30 days. Yep.
Quick question. In regards to the cost optimization, what does that entail?
Yes. So it's a pretty cool feature. Ultimately, we have a handful of options on the right sizing tab here. Ultimately, it just looks at usage and limits, and you can choose the strategy you want. And based on that, Commodore will provide you with recommendations based on the existing and historical usage. It's not an exact science. Like the numbers, they're more so estimates. So I know we do have a lot of interest around this. So we are working on developing this feature and adding more capabilities. But that's a high level overview. So yeah, the numbers, I would use it more for guidance than biblical truth, but it can be pretty useful.